Today we're looking at the slope of a line. This is the beginning of chapter 5. So I'm going to work out these problems on this practice page with you. First thing we want to do to find the slope of a line from a graph, and let me zoom in here, is we want to pick two clear points on the graph. And then we're going to count because slope is our up and down over our left to right. So first I'm going to mark 2 points on this graph. This is a clear point here because the line is perfectly going through the center of the square. And we have a clear point here. And so now what I want to do to find my slope is I'm going to count. I want to walk from this dot to that dot, but I can only move in a triangle. And so I'm going to count my triangle. And I've got 1, 2, 3, 4, 5 up. And 1, 2, 3 to the right. So my slope is 5/3. Now let's look at example 2. If I pick two clear points on this graph, there's no way for me to make a triangle here to get from this point to this point. So what I need to then look at is, if you remember from last year, we have our guy trying to walk the line, and we walk lines from left to right like reading a story. And so if I were to be walking on this line from left to right, I would be going uphill, which is why my slope is positive. Here we have two lines that you cannot make a triangle out of, and so when we picture ourselves walking on the line, this guy right here isn't walking uphill or downhill. He's on a flat line, so your slope here is 0. And this guy's bummed because he can't walk up this line, so this slope is undefined. You cannot walk up a vertical line, and so we call it undefined. Now we're going to look at finding slope from 2 points. Now remembering that slope is up and down over left to right, when I find the slope from 2 points, I'm going to connect my y values on the top, and I'm going to connect my x values on the bottom, and then I'm going to think of a number line. So from 4 to 5 on a number line is to the right, so it's positive 1 step, and from 4 to positive 7 on a number line is to the right 3 spaces, and then we just write this as a fraction. So here I have my slope is 1/3. And I don't need to put the positive sign there. All right, let's look at number 5. I'm going to connect my y's on the top, connect my x's on the bottom, and I'm thinking of distance on a number line. So from 3 to 6 on a number line is to the right 3. And from 8 to 1 on a number line is to the left, which is -7. And so we write this as a fraction. And we have m is equal to -3/7. And just to point out that it doesn't matter if I have the negative next to the 3, next to the fraction bar, or in the bottom, as long as it's there somewhere. Alright, connecting my y's on the top, connecting my x's on the bottom. From 7 to 7 on a number line is 0. I don't even need to do this, but from 2 to 4 is to the right 2. And so my slope is 0, which would be the flat line here that the guy's walking across. All right, from 7 to -2 on a number line is back 9 spaces. From -1 to +4 on a number line is to the right 5 spaces. And so my slope is -9/5. From 6 to 9 on a number line is +3. From 1 to 1 on a number line is 0. And since we can't have a 0 in the denominator of our fraction, this is undefined. So it's okay to have a 0 on the top, but it's not okay to have a 0 on the bottom. Alright, from -6 to +4 on our number line is to the right 10. From -3 to +3 on a number line is to the right 6. And so our slope is +10/6, which can also be reduced to 5/3. Okay, let's look at what this would look like on a table. So if you remember from T-charts, this is our x and this is our y. So I want to find the distance from 14 to 7 and from 2 to 1. So from 14 to 7 on a number line is 7. And from 7 to 14 is 7. 1 to 2 is 1. So here our slope is 7/1. Here we are on a graph. We need to pay attention to our units because we're counting by tens on the x, and we're counting by twos on the y. So if we have two clear points here and here, I'm going up 1 and over 1. So up 1 and over 1. And then I need to keep track of my units. So going up 1 is actually going up 2, and going over 1 is actually going over 10. And we can reduce this to 1/5. And remember, if I'm walking from left to right, this guy's going uphill, so my slope is positive. And now if I'm walking from left to right here, I'm going downhill, so I know my slope's going to be negative. Alright, we're counting by 16s and we're counting by 1s. So two clear points. I'm going to the right 1 and down 1. So going down 1 is actually a -16, and going to the right 1 is a +1. So down to the right. Now we're going to draw a line with the given slope. So I'm going to go get a graph paper. We've got a point at 3, -2, and a slope of 3. So our point is 3, -2, and our slope is 3. But slope needs to give me directions that are up and down over left to right. So if I don't have anything telling me what to do, I can always put a 1 under it. So I'm going to draw my graph. Okay, so I know I have a point at 3, -2. This is x, this is y. So I'm going to go over 3, down 2, and put a point. And from there, I know that my slope is up 3 to the right 1. So I'm going to go up 1, 2, 3 to the right 1. And I have my line. Now we have a point at 0, 4, and a slope of -1. And so since my slope is not giving me directions, I'm going to put a 1 under it. This means I'm going to go down 1 to the right 1 from my point. And draw my graph. I have a point at 0, 4, so I'm not going to go left or right at all. I'm going to go up 1, 2, 3, 4 and put my point. And from there I'm going to go down 1 to the right 1. And as you can see, that's a negative slope, because if I were walking left to right, I would be going downhill. Last example, we have a point at -2, 3, and I have a slope of -5 over 3. So from my point, I'm going to go down 5 to the right 3. And I'm going to start at -2, 3. So that's back 2, 1, 2, up 1, 2, 3. Here's my first point. And from this point, I'm going to go down 5 to the right 3. So down 1, 2, 3, 4, 5, 1, 2, 3. And there's my line. So this is finding slope mathematically from a graph, from a chart, and from graphing a point and slope.